Hi, in this video we're going to look at how to derive the quadratic formula by the method of completing the square. You may have seen this as a way to solve quadratic equations when factorization is difficult. It's not necessary to know how to derive this formula for GCSE maths, but I thought I'd include this video as an interesting aside as it links in with my video on how to complete the square, which you do need to know. And you may also have wondered where the quadratic formula comes from. So let's begin. The generic form for a quadratic expression is ax squared plus bx plus c, where a, b and c are constants. For example, we could have a equals 3, b equals 2 and c equals 4, in which case the quadratic expression would be 3x squared plus 2x plus 4. Let's make the generic quadratic expression equal to 0. This can now represent all quadratic equations equal to 0 because a, b and c can be any value. So let's now rearrange this equation for x. First, let's leave all terms involving x on the left-hand side and move the c to the right-hand side. We do this by subtracting c from both sides. So we now have ax squared plus bx is equal to minus c. Next, take out a as a factor on the left-hand side. This is because completing the square only works if the coefficient of the x squared term is equal to 1. Then ask yourself, what do I need to multiply a by to get ax squared? It's x squared, so write x squared in the bracket. The next one is a bit harder, but ask yourself, what do I need to multiply a by to get bx? The answer is b over ax. You can see this because b over ax multiplied by a is bx because the a's cancel. So we write b over ax in the bracket, and then we make this equal to minus c. Next, divide both sides by a. This gives x squared plus b over ax is equal to minus c divided by a. This is now in a form where we can complete the square. First, change the x squared term to x. Then, add half the coefficient of the x term. Half of b over a is b over 2a, so we can add this to the x. Then, square the result and subtract the square of the second term, which is b squared divided by 4a squared. Then make this equal to minus c divided by a. Next, add the b squared divided by 4a squared to both sides so that we now have x plus b over 2a squared is equal to b squared over 4a squared minus c divided by a. We can now combine the two fractions on the right-hand side of the equation into a single fraction. To do this, ask yourself, what is the lowest common denominator of 4a squared and a? It's 4a squared, as both a and 4a squared will go into 4a squared. So the new denominator is 4a squared and the first fraction can stay the same. But for the second fraction, what do we multiply the a by to get 4a squared? It's 4a. So we have to multiply the top by 4a too. So we now have b squared over 4a squared minus 4ac divided by 4a squared. Now that the two fractions have the same denominator, we can now add. So we get b squared minus 4ac divided by 4a squared. Next, take the square root of both sides to eliminate the square on the left-hand side. Don't forget that when you take square roots, you have to consider both the positive and the negative result. For example, the square root of the number 9 is both minus 3 and plus 3. So we now have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac divided by 4a squared. Next, to get x on its own, subtract the b over 2a from both sides. So we now have x is equal to minus b over 2a plus or minus the square root of b squared minus 4ac divided by 4a squared. Now notice how we can take the square root of both the 4 and the a squared. The square root of 4 is 2 and the square root of a squared is a. So we can change this to 2a and the square root is now only on the numerator. Finally, as both denominators are now 2a, we can add these two fractions to arrive at the quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's how you derive the quadratic formula by the completing the square method. If you'd ever wondered how it was derived and why completing the square is useful, I hope you found this video helpful. If you did, please like and subscribe to my channel, and thanks for watching.